All right, objective 49. Let's do number 1. These are ellipses, and we want to be able to sketch them, and we know that they're easy in standard form. So first thing I want to do when I sketch an ellipse or a hyperbola, which is coming up, is I want to get the x's together. I want to get the y's together, which, oh, good news, there's no y, and move constants to the other side. So there they are, right? X's together, y's together. Now I want to complete the square. Now, luckily, I won't have to on the y, so that's good. But I do on the x's because it's got that middle term. I'm going to have to complete the square. So in order to do that, I got to factor out an 8 and be left with x squared minus 6x. And then, like I said, I'll leave this guy alone for now. And I have that. Now, complete the square. Half the middle number is -3. Squared is 9. So I'm going to add 9 to this side, but I'm going to add 72 to that side. Hope that makes sense, because the 9 got multiplied by an 8. Now, I can go ahead and finish this up. This is going to be 8 times x minus 3, always half the middle number, plus 3y squared equals, and what do I have here? Is that 120? That's 50 and 70, so 120. So there you go. Now remember, ellipses in standard form are always equal to 1. So at this point, I'm going to divide everybody by 120, and it'll be equal to 1. And the good news is, hopefully, these reduce. So x minus 3 squared over something plus y squared over, it looks like 40 equals 1. And how many times is 8 going to 120? What is that, like 15 times? Yeah, 15 times. So 15. All right. Now the fun part. How do we graph it? All right, let's start. First off, we're going to go 3 in the x and 0 in the y. So 3 in the x and 0 in the y is right there. So that's our center. So the center is at 3, 0. Then in the x direction, we're going to go root 15. So root 15, that's almost 4. And those we will call the covertices. They're in the x direction, so I'm going to take the center, and I'm going to add or subtract root 15 to that center. And again, it's almost 4. So 1, 2, 3, 4. Little Barbara Streisand there. 1, 2, 3, 4. And there it is. Those are our covertices. Now our vertices. Now, how did I know those were covertices? Because 15 is smaller than 40. So the vertices are in the y direction. That's the bigger number. And they are square root of 40, right? Which is, if you want to be proper, 2 root 10. So I would take the center and I would add and subtract to the y value 2 root 10, right? Now, what is root 40? That's a little more than 6. So I'm going to go up 6, 2, 4, 6, a little more. Go down 6, a little more. Boom. There's your vertices. And then the most confusing is the foci. The foci are, I do this weird triangle thing, right? Where I do the opposite of the sign in between. So I'm going to subtract those two numbers, and that's how far away the foci are. So the foci are 40 minus 15, which is 25, square rooted. So their root 25 are 5 units in whichever number was bigger in the y direction. So 3, 0 plus or minus 5. And so you could write that as 3, 5 and 3, -5. And those would be your foci. So there's a focus and there's a focus. And now you've got everything labeled, which is probably what they, oh, I'll go back and see what they wanted. And here is the equation, or the graph of the ellipse. So let's see what they wanted. I identified the center, did. Vertices, did. Covertices, did. Foci, did. Length of major axis, that's the longer one. How long is it? The major axis, I guess I should call that, I should say major because the other one's minor. So the major axis we know is of units, 10 units long, because it was 5 in each direction from the center. The length of the minor was root 15 plus root 15, or 2 roots of 15. So the minor was 2 root 15. That's how long it was. And the eccentricity is c over a, right? So our c is our distance to our focus, which is 5, and a is our distance to our vertex, which was 2 root 10. And so there is our eccentricity. Again, bad manners. If you want to get the hooker out of the basement, go ahead. Have a great day and stay happy.